Hi everyone, this is Xu from the Ohio State University. Our paper is Multi-Channel DMA-Accelerated MPI Intra-Node Communication, a hybrid adaptive framework with memory copy offloading. The proposed design in our paper will mainly benefit the scientific parallel applications that developed with the message passing interface libraries. As the number of cores keep rapidly increasing in modern CPU architectures, and as the communication workloads becomes heavier in these parallel applications, for the communication libraries like UCX or message passing interface, the intra-node communication and the data copy operation, especially with large chunk of data, has become a significant bottleneck for these libraries. Here is the figure shows the example of a point-to-point communication micro-benchmark for the MPI. As the message size increased up to 8 to 16 megabyte, we observe a significant performance degradation with the existing CPU data copy operations because of the limit of cache size. And the first important innovation in our paper is to propose an enhanced DMA-based multi-channel data copy design to offload data copy of workloads from CPU processor to DMA engine. And in this design, we introduce a channel manager process to our DMA-based data copy framework to reduce the heavy overhead of multi-channel operations. With this design, we combine those implementation with existing kernel-assisted CPU data copy operations in state-of-the-art MPI library and form a hybrid intra-node communication framework that can deliver the best performance for all the message size range. Here is some example of our performance results. First, for the collective or reduce of 32 processes, we observe close performance between our proposed hybrid design with both kernel-assisted and DMA-based data copy design for small messages, but for large messages up to 64 to 128 megabyte, we observe more than 15% improvements compared to the kernel-assisted performance. Here is some example performance of our mini application kernel called 3D Stencil. Compared to the kernel-assisted methods, we observe up to 27% of improvements in reduced execution time. And what's more important for the communication and computation overlap compared to the current existing single channel DMA offloading design, our proposed multi-channel design is able to deliver 18% improvements in the communication and computation overlap.